Let f be the function defined, as you see here, on which of the following intervals is the graph of y equals f at x concave down. So concavity we can determine by looking at the second derivative, and we're given f right here. So the first thing we need to do is take the first derivative, which means we're taking the derivative with respect to x of this interval that has a constant in the lower bound, variable in the upper bound, of all of that stuff dt. So when you're taking the derivative of an integral, they're inverse operations of each other. So you just want to take this variable x and you want to substitute it for the variable that's inside your integrand. So f prime is going to be 2x cubed minus 15x squared plus 36x. And then you want to take the second derivative because we're looking at concavity, so just take the derivative of this like you would any polynomial and set that equal to 0. So if we're looking at concave down, then we want f double prime to be less than 0. We need to factor this. It's going to be easier to factor if we take out a common factor of 6. So that's going to leave us x squared minus 5x plus 6 equals 0. And factoring the parentheses, we need factors of 6 that add together to give negative 5x, so we're going to have a 2 times 3 for the 6. Both of them are going to have negative signs so that the inner and the outer product give us a negative 5x. Now if we set each one of those factors equal to 0, we're going to get x equals 2 and x equals 3. You can ignore the 6 because it's never going to equal 0. So the zeros for that polynomial are 2 and 3. Now you can test each of these subintervals using this factor and this factor right here, but remember that when you have x squared minus 5x plus 6, that's a parabola opening up. So the second derivative graph looks something like that, which means the second derivative is going to be positive on this interval, negative on that interval, and then positive again. We're looking for where f double prime is less than 0, so that's going to be on the interval from 2 to 3 only, so our answer is D.